All right, so we've all been there, right? Chatting with an AI, asking it stuff, and getting these wild human-like answers. It's pretty cool. But what if AI could do more than just talk? What if it could actually act on your behalf? That's what we're diving into today. This huge shift from chatbots to what you might call action bots.
And yeah, that's really the big question, isn't it? We're talking about going from just, generating some text to a world where an AI can take a goal you give it and actually go do it. That's a massive leap. So let's unpack how we actually get there.
Okay, so to get this, we've got to start with the tech that makes all this possible in the first place, the large language model. You've probably heard it called an LLM.
So think of an LLM as the engine, right? It's the core brain power. It's been fed this insane amount of information, books, articles, basically the whole internet. And that's why it's so incredibly good at talking and writing like a human. Anytime you use something like ChatGPT, you're talking directly to one of these LLM brains.
And let's be real, they're ridiculously powerful. I mean, they can take a super dense report and just summarize it for you. They can translate languages in a flash, or even write that polite email you've been putting off. This amazing ability with language, well, that's what made AI a household name, basically overnight.
But here's the catch. For all that brain power, there are some really important things LLMs just can't do on their own. Why? Because they're totally isolated. The best way to think about it is like a brilliant brain stuck in a jar. It doesn't know what the weather is right now, it can't look at your files, and it definitely, absolutely cannot book a meeting for you.
And that right there, that's the heart of the problem. The LLM understands what you're asking. It knows what "when is my next meeting" means, but it has zero way to actually connect to your calendar to find the answer. It's completely locked out of all the real-time personal stuff we use every single day.
So the big question for developers was, how do we get this brilliant brain out of the jar and connect it to the real world? Well, the first big attempt at solving this was something called an AI workflow.
An AI workflow, it's basically just a recipe, a set of instructions. The human developer tells the AI, okay, step 1, do this thing with this tool. Step 2, take that result and do this with this other tool. It's a totally fixed step-by-step process. Every single move is programmed by a person. So let's take this content creation example. A person gathers up a bunch of research links, then an AI tool automatically kicks in to summarize them. After that, a different AI tool takes those summaries and writes a first draft of a blog post. See? It's automation for sure, but it's super rigid. It can only follow the script it was given. No more, no less.
And here's the biggest problem with that. What if the blog post draft is just bad? The workflow has no idea what to do. It can't fix itself. A person has to step in, try to figure out what went wrong, change the instructions, and then run the whole thing from the top. There's no learning, no adapting. It's just stuck.
And that brings us to the next massive leap forward, the real game changer, the AI agent. This is a totally different and way more powerful way of thinking about things.
This right here is probably the simplest way to put it. Workflows follow a script. Agents write their own. A workflow is like a puppet on strings. An agent, you give it a goal, it looks at the tools it has, and it figures out the steps all by itself.
And when you break it down, the differences are just huge. In a workflow, the developer makes all the decisions up front. But with an agent, the LLM itself is the one calling the shots. Instead of a fixed list of steps, it plans on the fly. And this is a big one. Instead of you having to fix its mistakes, it can actually look at its own work and try to improve it. The whole system goes from being scripted to being driven by actual reasoning.
So you might be wondering, how does an agent actually do all this? Well, it's basically a system with 3 core parts. First, you've got the brain. That's the LLM, doing the thinking and planning. Then you've got memory, so it can remember what it's already tried, what worked, what didn't. And finally, and this is crucial, you give it tools. The ability to actually do things, like search the web, check a file, or shoot off an email.
Now, obviously, if you're going to give an AI the power to act in the real world, you need some serious safety measures. That's where guardrails come in. These are just rules and limits to stop the agent from, accidentally booking you 1,000 flights to Fiji, or getting stuck in some crazy infinite loop trying to solve a problem. Safety here is absolutely non-negotiable.
Okay, so we've got an agent with a brain, memory, and a bunch of tools. But how does it actually connect to all the different apps and websites out there? I mean, there are thousands of them. This turns out to be a gigantic technical headache.
Think about it. Right now, the digital world is kind of like the Wild West. Every single AI and every single tool speaks its own unique language. So if you want your AI to talk to your calendar, you have to build a custom connection just for them. Then if you want it to talk to your email, you got to build another one.
This gets messy, fast. It's what engineers call the N by M problem. If you have, say, 10 different AIs and 100 different tools you want them to use, well, do the math. That's 1,000 individual connections you'd have to build and maintain. It's a total nightmare. It just doesn't scale.
So what's the solution? It's actually pretty elegant. You create a universal standard. It's just like a universal travel adapter. You know, instead of having a different plug for every country you visit, you just have that one little adapter that connects to everything. It's the same idea.
And this completely changes the math. Instead of n times m, the problem becomes n plus m. Every AI just has to learn how to connect to the standard once, and every tool just has to connect to the standard once. It's so much simpler, and it's exactly what this new open protocol is all about.
It's called the Model Context Protocol, or MCP for short. And yeah, it really is that universal translator we were talking about. It provides one standard way for an agent to securely ask for information or tell a tool what to do, as long as that tool also speaks MCP. This protocol, it's the key that finally lets the agent out of the jar and into the real world.
All right, let's zoom out and pull this all together. Let's look at the big picture of how we got here.
So here's the evolution, right? First, we had the LLMs, these powerful but totally isolated brains. Then, we created workflows, which are basically like human-scripted robots for simple tasks. The next big step was agents. These are the autonomous systems that can actually think and act on their own. And finally, you have something like MCP, which is the universal key that lets those agents actually connect to and interact with everything else.
And that brings us to the really exciting part. This isn't just a thought experiment anymore. This is really happening. So I'll leave you with this question. If you had an AI agent that could truly act on your behalf, what's the very first goal you would give it? What's that one tedious, annoying, or complex thing you'd finally get off your plate? Definitely something to think about.